Hi, my name is Yalley. In this presentation, I'll show you how to formulate linear programming inequalities in 3 steps. So, what are linear programming inequalities? Linear programming refers to a mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. Before you can solve or formulate linear programming inequalities, there are some prerequisites. Number one, you need to have basic knowledge in algebra. Algebra refers to the use of letters and numbers to make mathematical sentences. Two, you should be able to solve two or more systems of linear equations. Linear equations refer to mathematical sentences with equal to sign. Three, you should have a fair introduction to linear inequalities. Linear inequalities refers to mathematical sentences with symbols like less than, greater than, less than or equal to, or greater than or equal to. Let's do a recap of how linear programming systems come about. Linear programming problems are usually real-life problems. Managers in businesses and engineering firms try to optimize manufacturing products. They try to maximize profits or minimize cost in the line of manufacturing. In this example, a small firm builds two types of garden shed. Type A requires 2 hours of machine time and 5 hours of craftsman time. Type B requires 3 hours of machine time and 5 hours of craftsman time. Each day, there are 30 hours of machine time available and 60 hours of craftsman time. The profit on each type A shed is £60 and on each type B shed is £84. Formulate the appropriate linear programming problem. Now, when we have a problem like this, our first step is to try to bring out all the variables that have been given to us in the problem. For instance, in this problem, you can see that time is a variable. Type A requires 2 hours. Type B requires 3 hours. That means we can use 2 and 3 to form an equation or an inequality with respect to time. Moreover, we can see also that craftsmen who work on type A require 5 hours and those who work on type B also require 5 hours. This means we can use 5 for type A and 5 for type B to also form an equation or an inequality. Now, we also see there are 30 hours of machine time available and then 60 hours of craftsman time. This means the equation for machine is constrained to 30 hours and the equation for craftsman is also constrained to 60 hours. Now, we are also told that the profit on each type A shed is £60 and the profit on each type B shed is £84. This means £60 is a constraint on the profit for type A and £84 is also a constraint on type B. This means we can form our profit equation using £60 and £84. Let's look at how this is done. So, because we have two type of sheds that we are working on, we are going to introduce two variables to represent these sheds. So X will stand for the number of type A sheds produced daily, and then Y will also stand for the number of type B sheds produced each day. So remember, the first step for solving or for programming your inequalities is to identify the variables involved. Alright, so with the variables formulated as x and y, we can go ahead and group the values and constraints that we need to form our inequalities. So when it comes to machine time required by A is 2 hours, and machine time required by B is 3 hours, but the entire system have only 30 hours available. That means that machine time cannot be more than 30 hours. So cannot be more than in mathematics is also known as less than or equal to. Less than or equal to. It means that 30 hours is the cap. We can't go more than 30 hours. In the same way, when we look at the craftsman time for A is 5 hours and for B is also 5 hours. However, we are constrained to 60 hours of craftsman time. With this in mind, it means we can form an inequality with 5 hours of craftsman time from A and 5 hours of craftsman time from B, which is restricted to 60 hours. That one too cannot be more than 60 hours. So we are going to use the same inequality sign, less than or equal to. But when it comes to the profit, shed A's profit is 60 pounds and shed B's profit is 84 pounds. With this in mind, it means our profit is a variable of 60 pounds times the number of shed A that is produced plus 84 pounds times the number of shed B that was produced. So the implication is we can write these constraints to represent the information that was given in the question. So for machine time, we are going to have 2 times the number of shed A produced, which is x, so 2x, plus 3 times the number of shed B that was produced, that is 3y, which is constrained to 30 hours. So we have 2x plus 3y less than or equal to 30 hours. In the same way, for craftsman time, for A we have 5 hours and for B we have 5 hours. That means 5x plus 5y, and the entire system have only 60 hours available for craftsman time. So that would be 5x plus 5y less than or equal to 60. But the number of shed produced for type A and type B cannot be negative. So we have to also write that inequality as x representing the number of type A produced greater than or equal to 0, and then y representing the number of type B produced greater than or equal to 0. Then we are left with the profit equation. So the profit equation, from the information, we are not restricted as to how much profit we can make. So the profit is just the number of shed A produced multiplied by profit per shed, which is 60 pounds, and then 84, which is also the profit for shed one shed B produced. So we have 60x plus 84y equal to our entire profit. So in summary, this equation for profit and the inequalities, 3 inequalities, are going to be our constraint for us to formulate our inequality problem. So we have P equals 60x plus 84y. Since it is profit, every production line would like to maximize it. So we have maximize P constrained to 2x plus 3y less than or equal to 30, and x plus y less than or equal to 12, x greater than or equal to 0, and then y greater than or equal to 0. Excellent. So this is example 2 for you to practice what you've learned so far. Go ahead and pause the video and try to solve this example by using the principles that were applied in example 1. Remember the 3 steps. Great. In case you are facing challenges navigating example 2, you can use what I have provided here to help you navigate the problem. I have shown how you can navigate this problem step by step. Also, the continuous dot refers to where you need to provide answers so you can formulate the inequalities required for the problem. Good luck. You can contact the instructor for more explanation. Congratulations, you have made it this far. Now, you have the tools to formulate linear programming inequalities from a given problem. Now, after formulating these inequalities, we need to solve them. However, that is beyond the scope of this presentation. I recommend that you learn how to do that by using mathematical content-specific softwares like GeoGebra. Thank you.